Hello, good day viewers. In this tutorial, we are going to evaluate these three summation problems. If you could remember in our previous lesson, I have shown you the formula to apply whenever you are given a summation. And we are going to apply those formulas in simplifying or evaluating these summations. Let's get started with the first one, which is the summation of 100 minus 2r, for which r begins with 1 and stop at 6. All right, here's our first problem. To simplify this, we can break it into two terms. Which is the same thing as taking the summation r from 1 down to 6 of 100, then minus the summation again r from 1 down to 6 of 2r, which we can further break down because we have a constant times a variable, which means that the constant can multiply the summation according to one of the rules. So this is the same thing as the summation of 100, which is a constant, r from 1 down to 6, then minus 2 multiplied by the summation of r from 1 down to 6. So now we can apply the formula. What can you remember about a constant? If you're evaluating the summation of a constant, if and only if it begins with 1 and stop at a certain number, you can just take that constant and multiply by the certain number. Let me write the rule for you here. If you're taking the summation of a constant c, for example, for which the value begins with 1 and stop at maybe n, this is the same thing as this upper limit multiplied by the constant cn or nc, all the same. But what if we have a variable to the first power or first degree? If it is a constant, for example, if you're taking summation of let's say x, or should I use k? It could be any variable for which this k begins with 1 and stop at n. This is the same thing as n multiplied by n plus 1 divided by 2, for which the n here is just the upper limit. So let's apply this in simplifying this. So the first one here, since it is a constant, just multiply it by the upper limit. You're good to go. It's just like taking 100 plus 100 plus 100 after 6 places, right? So we have 100 multiplied by 6, then minus this 2. What about this one? Remember, we say we are going to apply this formula, which is n times n plus 1 divided by 2. But here our n is 6, right? So we have the whole of this multiplied by n, that is 6, multiplied by n plus 1, right? This is n plus 1, that is 6 plus 1, 6 plus 1, then the whole of this divided by 2. So this is the same thing as 100 times 6, that is 600, minus this 2 here will cancel with this 2, right? Because we are multiplying. So we only have minus 6 here times 7, 6 times 7, because 6 plus 1 is 7, and we have 6 multiplying 7. So this is the same thing as 600 minus 6 times 7 is 42. And what is 600 minus 42? That will give us 558. So this is equal to 558 altogether. So the moment you take the summation of the whole of this, you're going to get 558. But if you could recall, I told you if you don't want to use formula, you can simply take this when r equal to 1, then you add it to when r equal to 2, when r equal to 3. You keep on simplifying, taking series of these times after 6, then you stop. Simplify all, you have to get this 558. Now let us take the second one. All right, here is our second problem. We would like to evaluate the summation of 2r squared minus r, for which this time around r begins with 5 and stops at 7. In our previous example, you can see that r begins with 1. So we have a different case here. So you have to be very careful because all the formulas we have are in a situation where r begins with 1 and stop at a certain number. So we have to evaluate this into such format. So let's get started. This is equal to, you take this one separately, that is 2 multiplied by the summation of r squared, for which 2 is constant, you can bring it out. R begins with 5 and stop at 7. then you subtract, then you take the summation of r, for which r begins with 5 and stop at 7. So there is something very important you should understand here. There is something left behind, which is what? From 1 down to 4. So if we can subtract the summation from 1 down to 4, we are good to go. Let me show you what I mean. This 2 is constant. Let's just leave it outside. So we can now take, let me put a bracket here. We can now take the summation, entire summation, for which r begins with 1. Though we know it begins with 5, but this is just logical. Then we subtract the whole of the summation r squared, for which r begins with 1 and stop at 4. Because we have from 5 down to 7, which means that from 1 to 4 has been neglected. So this is why I have wanted to take the whole summation from 1 to 7. Though we know from 1 to 4 is missing, so we're going to subtract it. So after you have subtracted it out, what is left is what? The summation from 5 to 7. That is just the logic. If you want to start with 1, because that is only when you can apply the formula. Then we do the same thing here, minus. We take the summation of r from 1 down to 7. But we have to subtract the summation of r from 1 down to 4. So if we simplify this, we're good to go. So now let us evaluate it separately. Remember, if you have the summation of k squared, for which k begins with 1 and stop at n, the formula is given as what? N multiplied by n plus 1 multiplied by 2n plus 1 divided by 6. This is the formula for k squared. But if it is just k, for which k begins with 1 and stop at n, this is equal to n multiplied by n plus 1 divided by 2. So now let us substitute everything here, for which our n is 7 here, and our n is what? 4 here. So let's do that. So this is equal to 2 multiplied by what? For r squared, we are going to apply this formula, for which our n is 7. This is n, which is 7, multiplied by n plus 1. 7 plus 1 is 8, multiplied by 2n plus 1. That is 2 times 7 is 14 plus 1 is 15. Divide by what? 6. That 6 is constant. Then we minus, this time around, our n here is 4. So we have 4 outside, multiplied by 4 plus 1, which is 5, multiplied by 2 times 4, which is 8 plus 1 is 9, divided by 6. We are done with the first bracket. Then minus second bracket. Remember, this is just r without any power. So we are going to apply n times n plus 1 divided by 2. N, which is 7, multiplied by n plus 1, that is 8. 7 plus 1 is 8. Then divide by 2. We minus, this time around we have 4. So it will be 4 multiplied by 4 plus 1, which is 5. Then divide by 2. The moment we simplify this, we are going to get our final answer. So the whole of 7 times 8 times 15 divided by 6 will give us 140. So this is equal to 2 multiplied by 140. The minus, we take 4 times 5 times 9 divided by 6. That is going to give us 30. Then we go to the other bracket. We have 7 times 8 divided by 2. That will give us 28. The minus, we have 4 times 5 divided by 2. That will give us 10. This is equal to 140 minus 30. That will give us 110. Then that 110, we multiply that by this 2, and that will give us 220. 220. The minus 28 minus 10 is 18. So finally we have 220 minus 18. That will give us 202. 202. And this is said to be the summation of the whole of this series. Now let us take the last one. And here is our last problem. We would like to evaluate the summation of x to the power of 3 minus 2x squared plus x minus 7, for which x begins with 1 and stop at 4. So let's get started. We're going to first of all break it down into how many summations? 1, 2, 3, 4. Let's do that. We have the summation of x to the power of 3 minus 2 times the summation of x squared plus the summation of x, the minus the summation of 7, for which all of them begins with 1 and stop at 4. All right, so what is the formula for x to the power of 3? For x to the power of 3, let me write it down here. Already we have that of x squared, x, and a constant. Then for x to the power of 3, if you have summation of maybe k to the power of 3, for which this k begins with 1 and stop at n, this is equal to n squared multiplied by n plus 1 squared, then divide by 4. Already we know that of when we have k to the power of 2, for example, for which k begins with 1 and stop at n, you know this is equal to n multiplied by n plus 1 multiplied by 2n plus 1 divided by 6. Then the last one is when we have just k without power. K begins with 1, stop at n. This is equal to n times n plus 1 divided by 2. And if you have a constant, for example c, from 1 down to n, this is just nc. Because we have all of this, constant, k, k squared, and k to the power of 3, for which we just use x here. They're all the same, they are just variables. So let's start with this one, for which n here is equal to 4. So we are going to plug it in here. Wherever we have n, we replace it with 4. So this is equal to n squared, that is 4 squared, multiplied by 4 plus 1. Or should I write it as 5? Yeah, let me just write it as 5, because 4 plus 1 is 5, whole squared, then divide by 4. We are done with this one. The minus this 2, which is a constant, multiplied by the summation of x squared, which is what k squared here. We have n times n plus 1, which is 4 times 4 plus 1 is 5. Then multiply by 2 times n, that is 2 times 4 plus 1. 2 times 4, 8 plus 1 is 9. Then divide by what? Divide by 6. Then we move on. That is when we have x without exponent. We're going to use n times n plus 1 divided by 2. Because n is 4, we have 4 times 4 plus 1 is 5, then divide by 2. Then the last one, minus, when we have a constant, just multiply them together, the upper limit and the, so it will be 4 multiplied by 7. Let's simplify this. So this is equal to 4 squared is 16, multiplied by 5 squared is 25, divided by 4, minus, I think these two can divide these 3 times. So we only have 4 times 5 times 9 divided by 3. 4 times 5 times 9 divided by 3. Then plus, this is 20 divided by 2. Then minus, is it 28? Yeah, 28. 4 times 7 is 28. 16 times 25 is 400, divided by 4 will give us 100. So this is 100, minus, we have 4 times 5 times 9, which is 180. Then we divide it by 3, we have 60. then plus 20 divided by 2 will give us 10, then minus 28. So we have 100 minus 60, that will give us 40, then 40 plus 10, that will give us 50, then 50 minus 28, that will give us 22. So the whole of this will give us 22, which implies that the whole of that summation, which is this one, will evaluate to what? 22. As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.